we start?
Yes.
Yeah. A very good morning to one and all. So myself, Dr. Shruti Sridhar, a faculty member of Physics Department at IISER Tirupati. On behalf of the Outreach Committee, it is my pleasure to invite you all to grace the National Science Day celebrations. I also invite all the participants who are attending through the IISER Tirupati YouTube channel. We all know that National Science Day is celebrated in India on 28th February each year to mark the discovery of the Raman effect by Indian physicist Sir C.V. Raman on 20th February 1928. So for his extraordinary discovery, Sir C.V. Raman was awarded the Nobel Prize in Physics in 1930. So this event is celebrated as a part of 75 years of independence, India's independence, Azadi Ka Amrit Mahotsav commemoration, with a theme of integrated approach in science and technology for a sustainable future. So this celebration spans over two days of today forenoon and tomorrow both at forenoon as well as afternoon. So briefly, the outline will be like as displayed in the meeting. So today we have a series of events. This celebration series of events we have, starting with a welcome address by Professor Ambika, followed by exciting presentation from student clubs, Celestic and ECS. Then the final competition event on the communicating science and art, science art through art will be taken place. And finally, a short presentation by ISM Indian League. Yeah. So without further delay, I welcome Professor Ambika, the Chair Physics Coordinator and Academic Programs, and also a prolific artist, to address the celebration. Yeah, thank
good morning to
you, ma'am.
Yeah, good morning to all of you. Am I audible to all of you?
Yes, ma'am.
Oh, okay. Oh, and a very warm welcome to all of you who have joined on screen there for the 2 days Science Day celebrations from IISER Tirupati. Thank you, Ishwar, for coordinating this event. The 2-day celebrations are actually coordinated by our outreach team. My congratulations to all the members of the team, Annapurna, Ashwini, Ishwar, Nirmala, Robin, and Venkat. They have put together a very interesting events on the 2 days. So I welcome all of you for the 2-day events. And as Ishwar already pointed out, this year's Science Day theme is integrated approach in science and technology for a sustainable future, a very interesting theme. But today's half session is mostly devoted to science communication through art. So I thought I will present a few views, my personal views on this about science communication or the connection between science and arts, etc. I will share my screen and then I will show you a few slides and then I will conclude with a welcome to all of you. I hope my screen is visible.
Yes, ma'am.
Okay.
Please mute all.
So I'll present a few views, my views on science through arts.
Just a second, ma'am.
Okay.
Ma'am, can you please unmute yourself now? I have muted everyone.
Okay. So is that okay now?
Yes, ma'am.
So let me start with the intimate connection between science and arts. If you look at it, both of them are highly creative, exploratory, and it is an outcome of creativity of the human mind and the intelligence together. And if you look through history, science and arts have influenced each other. They perfectly complement each other. And scientific art arises from the blending of these two disciplines, science and arts. Now we come to the usefulness of arts in science communication. It provides a very useful information to the viewer. But the idea is you can project arts through a scientific viewpoint, but then it becomes visually appealing, even not even visually, even stories and fiction, all these things. If it has a scientific bent and it is based on scientific facts, it becomes all the more interesting to the reader and especially to students and other researchers. So scientific developments can be communicated to the public from an artistic point of view. Then it is more accessible, and moreover, it can be shared on a very diverse platform, online or otherwise. Lots of galleries, museums, stage arts, all these things can be used as platforms for communicating scientific ideas. So if you talk about science through arts, I would say artistic creations that can communicate scientific discoveries and scientific messages can be of different types. They can be stories or fictions. It can be paintings or sketches, or it can be performances like drama or short performances like skits. Even recently, we see lots of street art also communicating scientific themes, and nowadays digital art also. So I will touch upon a few of them, giving you some specific examples which I find very interesting. Let me go back to the story of Galileo and the Tower of Pisa. I'm sure almost all of you must have heard about Galileo Galilei. He lived during the time 1564 to 1642, that means 16th century. And even from school days, all of us have heard about this story, that Galileo went all the way up to the top of the leaning Tower of Pisa and threw down two balls, one a wooden ball and one an iron ball, and both of them reached ground at the same time. So it is not historically, I searched historically, people say this may not have actually happened, it's only a story. But even if it is a story, it conveys a very important message, a very important scientific invention, or let us say scientific discovery, that an iron ball and a wooden ball will take the same time to reach the earth, reach the floor. So this is just a cartoon. You can find lots of nice paintings on this also. I specifically took a cartoon because cartoon also is a way of communicating these things, which is much easier than doing through a proper painting. So the experiment just illustrates a very, very good scientific truth, even though it was done like this. It is much easier, or it can convey the idea much easier to a broader audience than saying that the velocity as it reaches the ground is square root of 2gh, or the time taken is root of 2h by g. These are complicated scientific formulas for a public, especially school children. But on the other hand, this cartoon or even the story that you must have heard from your school days makes it much simpler, and the picture stays in your mind. The fact of the story, how he went up, I mean, the inclination of the Pisa Tower is also very useful. Otherwise, how would have he performed this experiment, I wonder. But somehow it stays with you. So the idea stays with you, and that way, that very important truth about science could be communicated to you. So that I find is very interesting. Now coming to Newton, the next century, you must have heard about Isaac Newton and the story of the apple tree. So it's a legend. People say, historians say it is still a legend. A young Isaac Newton was sitting under an apple tree when an apple fell on his head, and immediately he said, aha, this is the law of gravity. But actual fact may not be like that. I recently went through another important historian where he says it was occasioned by the fall of an apple as he was sitting in a contemplative mood. But why should that apple always descend perpendicularly to the ground? That was what put him to some ideas and how he could come up with the law of gravity. This is about Isaac Newton, written by William Stukeley. So this is actually the correct thing. He was just sitting there, but you see all sorts of cartoons of this type where the apple is actually falling on his head, etc. So artists in that way, even storytellers or writers like that, have a little bit of flexibility and freedom to bend facts, because they want to convey an important message, and they want to convey it in such a way that it appeals to the public and to the general audience in a better way. So this actually, the apple tree was there. Fact is that apple tree is there, and I have seen this apple tree outside University of Cambridge. And in the recent cyclone of Eunice, that apple tree fell down. They are going to get back it from Woolsthorpe and again clone it and plant it again. So the story is correct. There was an apple tree in his garden, but little bit of exaggeration. But with that, even for school kids, with that exaggeration, the things become clear that this is how scientific facts are. And now going back to Leonardo da Vinci, all of you must have heard about Da Vinci as a great painter and an artist. But if you read about him recently, earlier I also thought like that. I thought that he studied all scientific things, like he went to cemeteries and looked at the anatomy of human figures, and he did lots of experiments with the water and fluids especially. I thought he was doing all that so that he can reproduce them in his paintings correctly. But now, as I read more and more about him, especially this recent article on the 500th anniversary of his death, I find he was basically a scientist. He was especially an expert in fluid mechanics, and he did lots of studies about fluid flow behind a wake and so all these things. And he made very clear and correct sketches about the fluid flow, vortices, how do they develop, etc. So you must understand that in those days when we never had a computer to solve Navier-Stokes equation, there was no digital medium or even printed medium through which all these things can be communicated and preserved. So he must have felt that whatever he acquired from his own experiments should be preserved for posterity. And in those days, that was the only medium to make these sketches. And then you find that what all things he could sketch, especially the flow behind a wake. That is what he has written in his notebooks here. And if you look at the recent computer-generated picture like this, it's very similar to that. So he could do it with lots of accuracy. And this is actually certainly a contribution to science because of that and because of his sketches. And that has been preserved over centuries. And again, coming to the most famous painting of Leonardo, that is the Mona Lisa. And people say he has used the Fibonacci sequence and the golden mean ratio on this painting. Later, people have discovered all this. There's a perfect balance, and the aesthetic appeal of the whole painting is because he has taken this golden mean ratio and put the whole figure inside a rectangle pertaining to that. So it's not very clear. I read in history, it is not very clear whether he knew about Fibonacci sequences, but I feel that he must have observed it in nature, because Fibonacci sequence and the golden mean ratio you see very frequently in lots of places in nature. And as a scientist, he must have observed all of them, and he must have thought how appealing it is aesthetically, and therefore he must have put them. That's what I feel. So this is also a place where scientific facts and this mathematical sequence has influenced the artist, and he could create such an everlasting art piece. And coming to recent times, nowadays we get lots of cartoons like that. This recently I got from lecture given by Mahesh. How do we explicitly show the difference between the classical world and the quantum world? Very interesting. So how classical world, everything is deterministic and pinpointing, while things are a little bit hazy in the quantum world. This could be conveyed to such a sketch very easily. Even to a school student can understand that. So that's my feeling. Now coming to the theme of this year's Science Day, Integrated Approach in Science and Technology for a Sustainable Future. So if you worry about a sustainable future, the first thing that comes to your mind is global warming and the consequent climate changes that is threatening the survival of every species on Earth. So extinction of species is something which we have to worry about immediately. And scientists even anticipate widespread other events like coastal land loss, agriculture economic collapse, food and water shortages, frequent and severe natural disasters also. So what can artists do in this context? They have the capacity to convey the message regarding climate changes and all such threats to humanity much better, because they make an emotional connection. That is the power of art. So one can use the power of art, communicate these challenges, and make the public aware, public as well as politicians aware of these threats, and force them to take some measures. That can be done through that. Let me show one or two sketches on that. This is a famous painting, Tree of Extinction by Alexis Rockman. He's just showing all the critically endangered species there. Forget about all these names here, but if you look at the painting itself, you get a feeling how these species can become extinct and how global warming, the color combinations itself tell you something about global warming, etc. So there is a clear-cut message there, which is very easily accessible and can go into the hearts of the public very easily. And I found this series of watercolor paintings by a graduate student, Jill Pelto. She has made it her mission to communicate these changes, global threats to humanity through such landscapes. And interesting thing is she's basing her sketches or watercolor paintings like this on facts. So this is about sea surface temperature increasing, etc. We know that, we are in fact experiencing that in the last 2 years. The increase in the sea surface temperature by even 1 degree or 1.5 degree has caused a lot of rare events in climate changes. We have seen a series of cyclones even going through the Indian subcontinent. So that message is made clear here. And as I said, this is much more easily communicable to the public at large than showing a graph like this. So this is a graph which shows the global sea level is rising. This is another picture showing the global temperature increases, etc. So this may be easy to understand and appreciate by a scientist with a training in that area. But in general, for a general public, this type of paintings, they carry a lot of information. This is again increase in forest fire activity by the same person, Jill Peltor. And this is about glacier mass loss that has happened over a few years. So she's again painting this with a nice painting like this. And then the facts are actually taken from such a graph here. So better than showing this graph, this painting will convey the message much easily. That is my point to stress here. And this double helix has been inspiring scientists and artists alike over over the last 60 or almost 70 years now. But I just want to show a performance, a stage performance based on that. This is called the Spr Synthesis Project. This is actually done by 3 collaborators, one a molecular biologist, Robert Sinsheimer, a dancer and choreographer, Pennington, and a visual artist, Susan Rankaitis. So they made a giant chromosome that is shown here as the background of the stage. And the performer was performing on the stage his dance of life. And then it contains genetic images on that chromosome. So this is actually a joint effort, which was actually staged on March 2003 on the occasion of the 50th anniversary of the I don't know whether I lose connection. Can you hear me?
Yes, now we can hear you.
Okay. So before I conclude, I will tell you how art can be inspired by science. For example, the patterns that we observe around us from scientific discoveries as well as from scientific themes, that has inspired artists for quite some time. Especially one immediate theme that comes to my mind is the fractal patterns that we observe around us in nature. That has inspired several artists, and one of them is Jackson Pollock, that there are so many such paintings by that artist. Then this is again coming into being. It's a painting by Ken Keller, and you can see he was certainly influenced by a large number of fractal patterns like this. And this is another one, where you can certainly see in this Sierpinski fractal and other things. This is called circular transition by Michael Coleman. So even scientific themes, scientific patterns and themes can influence artists, and just for visual pleasure, they can put it down so that it is engaging to the public, as well as the same time, people can appreciate the scientific content behind that also. So this is a Mandelbrot set. This is a sea of Mandelbrot set on which swans are seen. Then this is a set of orchids on a Cantor set. Again, Cantor set is a fractal, and these orchids display the concept that how the Cantor set are constructed, etc. And these are some embedded beauties. This is actually the basin boundary of a bistable dynamical system. And then some beautiful lotuses are embedded in them. So these are some of the things I wanted to say. Let me stop at this point, and I would like to welcome all of you to the 2 days of celebrations of National Science Day at IISER Tirupati. Thank you very much.
Yeah, thank you very much, ma'am, for enlightening us with such an insightful and inspiring address. Such a communicating science through such an art is have such an impact. So we will move on to the next session, presentation by Celestic Group on astrophysics in daily life. Celestic Group, are you there? Arun, can you make Suman as a co-host? Oh, okay, let me.
Done, sir.
Yeah, Suman.
Sir, can you unmute Amisha? Amisha Baiju.
Hello.
Please go ahead.
Okay.
Yes, yes.
Good. Okay. Thank you. Good morning, everyone. So this is Celeste, the Astronomy and Astrophysics Club of IISER Tirupati, and today we'd like to present a small overview on astronomy in society and how space science is moving towards a sustainable future. Astronomy in general is the discipline of science which is concerned with celestial objects and phenomena. These can be of varied types. It can be the things that we can observe with our naked eyes in the sky, like the sun, moon, and planets, or things that we need telescopes and other instruments to view, such as phenomena such as galaxies or dark energy or even black holes. So this is what basically astronomy is about. And these are some of the phenomena. This is the Crab Nebula. The second picture is an asteroid. Now you have on the bottom Milky Way. This is a artist renderation of a black hole and another of the planets in our solar system. These are quite nice to look at and interesting. And you might think that astronomy is a very streamlined field in which only people who study space sciences or astronomy specifically would work in, but it is not actually true. It is pretty diverse, and there are like scientists, engineers, and even doctors who are part of astronomical missions. Exploration of our universe is something which is not very streamlined. You do not go from the objective exactly, you do not go from your idea exactly to the goal, but in between, in the research that you do to achieve something, you achieve a lot of byproducts as well, which may be surprising and useful. And this is what happens in most of the astronomical missions. We do not often realize the extent to which astronomy has affected our daily lives. And some things which we kind of take for granted around us are actually results of astronomical research, the byproducts of them. And we will go through some of them in this presentation. Before that, historically speaking, astronomy has always played an integral part in our lives, especially with regards to timekeeping. The way we measure time has always been linked to astronomy. So if you see there, there is a picture of the lunar calendar 10,000 years ago, which are engraved on pebbles. And these are things which our ancients used to keep time. The motion of stars and moon is how they located both position and time in ancient times. And even the atomic clock, which is now the current standard for our time, was also formed using a former standard astronomical time scale called the astronomical ephemeris time. Now we will talk about the applications of astronomy in some of the sectors. First, we'll talk about the technology and aerospace sector, which is probably the field in which astronomy has had the most applications in. You would all be familiar with the GPS or global positioning system. It's pretty commonplace nowadays. You can get it on Google Maps and other global positioning devices. And this technology is driven by satellites, which rely on astronomical objects such as quasars and distant galaxies to accurately predict the position where you are on Earth. This is an image of a satellite orbiting the Earth, which helps in geolocation. Charge coupled devices. You might not see it in this form, but these are things which are located in every phone or camera nowadays to capture images. but this was initially developed for sensing astronomical data during astronomical missions and observations, which is pretty commonplace nowadays and has huge applications in our lives. Now let's talk about the energy sector. You might have heard of fusion, which is the process where two light atomic nuclei fuse to form a heavier nucleus. And this process actually leads to an immense amount of energy. And if it could be harnessed or controlled in some way, it would lead to a much better alternative for clean and safe energy. And the application of astronomy is such that the technology which is used to image X-rays in X-ray telescopes are now used to monitor plasma fusion. And if this technology could be properly used and harnessed, it would lead to like great development in our energy sector. And this is a picture of the world's largest fusion reactor called ITER. Now let's talk about medicine. When you think of astronomy, you might not immediately associate it with medicine, but astronomy actually has a lot of varied application in medicine. And there is a method, there is a technique called aperture synthesis. So you understand that in astronomy, our objective is to visualize faraway objects in great detail, and we need to know more about them. In medicine, also similarly, there are objects which are pretty close to us, but we want to image them as well in great detail. And for this, the technique of aperture synthesis, which was originally formulated by this Nobel laureate called Martin Ryle, for basically initially used in radio astronomy, is now being applied in a lot of medical imaging techniques, which we'll go through now. So this might be pretty familiar to a lot of you. This is a computerized tomography scanner, or CT scanner. This basically uses the technology of aperture synthesis to view our body, basically image it in great detail. And there are other scanners that are like MRI, PET, and you can even find it in applications of this in archaeology as well, to image like you might have heard of the case of Tutankhamun or like the Egyptian mummy. In all of these, they were MRI scanners were used to view the entire image and body position of the mummy, and it is quite interesting. Do go look upon it. And this is a NASA air purifier. So you know that in any lab conditions, in any research conditions, you need pretty clean environments. Like it should not get polluted. So the new non-contamination techniques and devices like air filters and clean room suits have been perfected from such astronomical research. So this air purifier actually can be used for people who are like extremely sensitive to any chemical changes in their environment or air, like people with allergies or asthma. And it is quite a useful finding. Now let's talk about some things that we see like randomly every day and we probably do not associate with astronomy. So this is a chemical oxygen demand photometer. You might have seen police checking your glass windows with this. This is used by the police to check if car windows are transparent and were initially developed for astronomers for measuring light intensity. And this is a picture of a high range COD photometer. So this is an image like when you go to airports or other high security areas, they put your baggage into a machine and it scans it for any explosives or any other harmful substances. So this is based on the technology of the gas chromatograph, which was initially developed for separation and analysis of compounds during astronomical mission. So this is a image which you can see of certain luggage being scanned through this gas chromatograph, and you can see like all the inside contents of the luggage. So also, you might be a lot of people might be familiar with this. This is the memory foam mattress. So the history of the memory foam mattress is quite interesting, as it was initially developed during the Apollo program. For like the command module, you needed good like support when you're driving the spacecraft. So this technology took off and now is like present everywhere, from seats to beds and of course mattresses and other applications. So it finds a wide variety of applications in our daily life. So now astronomy in general is quite an expensive venture, which consumes a lot of like monetary as well as other kinds of resources. And we need to think about the outcome of this with respect to the effort that we're putting into it, with regards to our Earth's future as well. Because, as you know, like a lot of pollution can occur through this emission of carbon, which astronomy uses up. So we'll talk about a few of the two of the major concerns right now, and we will discuss them in detail. So the first thing is reusable rockets. This is quite a new technology which has taken off, and they seem promising. Like, why wouldn't you like to reuse rockets? There is less amount of wastage of money and resources. But the thing is, like, initially they are quite promising. You can reuse a rocket, but the amount of effort which goes into it depends, and the amount of usability it has also depends on the number of launches it gets, which we yet have to verify and yet have to see about the promising features of it. So we will see about that in the future. So space debris is currently a very important thing in astronomy that we have to focus on. Space debris basically means that these are artificial objects which are present in space, like the remnants of mission, broken satellites. Like you can see in that illustration, there are a lot of junk in space. So these things can cause serious faults to missions and like launching. Like there are just objects in space floating around. We can't actually predict where they'll be, and it'll be a big, if it's not controlled, it'll be a big disaster in the future of space flight, as well as like for Earth environment as well. So we need to curb it very immediately. So you can check out a company called Astroscale, which came up with a proposal for a kind of space truck which could basically help clean space debris. And I think we need more of those sort of innovation in basically keeping our space environments clean. So I would like to, this was basically just an overview of astronomy in society and how we should go towards it with the thought of sustainability in our mind. I would just like to say about the scope of astronomy, because it is often regarded as something which is very niche, like only a particular set of people are are privileged to do. But it is not the case. Astronomy has an immense scope of inspiring people. Like, who hasn't stared at the night sky and wondered what lies beyond all those things? So it like develops a sort of curiosity in kids like no other, and it is very interesting to pursue as well. So I hope you guys would like to take it up in the future, or at least delve into it once, and you probably will see how amazing it is. And yeah, this is a reference. This is the references we used in our slide. And for further information, do check out the IAU astronomy page. They talk a lot about sustainability and astronomy applications in daily life. So that would be quite informative. Yes, and thanks for everyone for staying till here. If you have any questions, you can mail us. And thank you to Suman for helping me with the slide. And thanks to all for listening to this for so long. Thank you.
Yeah, thank you, Amisha, on behalf of Celestial Club. It's indeed a very nice presentation by portraying on how astrophysics has influenced other interdisciplinary branches of sciences and our day-to-day lives. So by using new tools and new instruments, which are actually came through the astronomy discoveries. Yeah, thanks. We'll go to the next, we'll move on to the next presentation and interactive session by ECS Club on sustainable environment. ECS Club, you can take over, and that way we explain how this interactive session is going to be organized.
Surely. So Gaurinanda and Akshita, you will be presenting now, so you can take over.
So there will be a few, 3 breakout rooms, right?
This room and 2 more breakout rooms would be there for our activity.
Okay, so I think since we are on live yeah, so what we can suggest is, we are suggesting is that So please stay kind of 1/3 of the participants in the main room, and there is an option of breakout rooms. So 1/3 of the participants can join in one breakout room, and rest of the participants in the second breakout room. So the main room, whoever stay here will be organized by one host from the ECS club, and the rest of the two breakouts will be hosted by two other hosts, ECS hosts. Yeah, I think it is clear, right?
Yeah.
Yeah, so there is an option on the screen, breakout rooms. So if you click on that, Arun, can you help with that?
May I intervene a bit?
Yes, yes, please, Anu.
Parth, we thought it is not with the breakout room, right? This is live streaming on YouTube. Whoever would like to join, if you can do it here, it would be.
Yeah, if it is, yeah, that's right. Main room will be more effective, and maybe you can make it short instead of prolonging spending more time on each presentation, each slide. Will that be fine, ECS part?
I think Parth is already in the other breakout room.
Sir, the two hosts have joined the two breakout rooms. So myself and Akshita are staying here, sir.
Oh,
So
okay.
can you please ask them to come back, Gauri Nanda?
Sure, ma'am. Sure, ma'am. Okay,
This is a confusion from your end. We didn't want any breakout rooms actually.
Okay, ma'am. I'll ask them to come back.
Thank you.
I sent them back to main session.
Mm-hmm. Yeah, Arun, maybe you can close that breakout room so that nobody can.
Yes, sir. I closed it, sir. No one
Already.
is there.
Okay, okay.
So people are here only, sir.
Yeah, Parth, you can. UCS, you can start with the presentation.
Okay, sir. So may I start?
Yes.
Sure. You go on.
Okay. Okay. So a very warm good morning to everybody who has joined here. Thank you so much for taking your time to join in this meeting. I'm Gauri Nanda and I have Akshita along with me. And we are going to present to you a few interesting natural phenomena that happen around us. And we are going to present slides so that it can become an interactive session and everybody can respond to the questions being asked. So I would like to go on to the presentation. Hope my slide is visible.
Yeah, it's visible, Gauri.
Okay. Okay. So, as I said, once again, a very warm welcome to everybody. Let's find the facts behind a few natural phenomena that are happening around us and which have already drawn our interest right from young age for many of us. So I would like to go on to the first phenomenon. I hope my GIF is visible here.
Yes.
Yeah, thank you, sir. So I hope everybody knows what's being shown in the figure. Can anybody please unmute and say what it is? Okay, then actually the Orion constellation is being shown here, and it shows a small change in the relative position of the stars. And so my first question is, do constellations change their position in the sky? Can anybody please unmute their audios and say?
Just a second. I think the participants are not able to unmute themselves.
We have to ask the co-host to like the host to unmute them.
Guys, you can answer via the chat option right now.
Yeah, you can raise your hand and you can say it or before it.
Yes, yes. So I think, yeah, given the kind of limited time, we can just, yeah, if there is a kind of delayed response or questions from the audiences, you can just go ahead and then explain the phenomena. Yeah,
Sure,
without
sir.
further delay,
Okay.
so that,
Okay, sir.
yeah, we can.
So actually the answer for the first question is no. The constellations do not change their position in the sky, and any shift is due to the relative positioning between the Earth and the stars, and because of the rotation of Earth on its own axis. And so constellations do not change their position in the sky. And now my next question is, why do we see different constellations throughout the year? So I think I'll have to say the answer again. The different constellations throughout the year is, of course, because of the seasonal changes. Like we see Orion during the winter and the Great Dipper during the summer evenings. And this is because of the revolution of the Earth around the sun. So different constellations result from the seasonal changes. And relevant question, how can the knowledge of constellations be useful to us?
Can I just say something?
Of course, ma'am.
Yeah, no, I don't know the answer. I'm just assuming the ancient people, our ancestors would probably use this for a positional relevance. They would see the same thing at certain points of time in the year, and that would be their marker or something like that. I don't know.
That's right, ma'am. Thank you so much. That's right, ma'am. The ancient people used to locate the stars and identify them for navigation purposes, as ma'am said. And it also helped us for agricultural practices because of the seasonal changes. People knew that this particular constellation will be coming in this season. So that helped us in agricultural practices. And even in the present days, we use it for naming and identification of constellations. When you take a star and say about it, we know which constellation it belongs to. So that is the relevance of constellations to our present day. Actually, the usage of constellations were more in the ancient time, as ma'am said. And thank you for interacting. Now I would like to hand over the presentation to Akshita. She'll be dealing with the next slide.
Yeah, Gaurinanda, you can now. So next slide, please. Guys, can you see what is seen in the GIF? Like, can you answer them? You can answer through your chats. Like, which phenomena can you see in the GIF? Any guesses? Okay, let me say. So the GIF shown here, the phenomena is tidal locking. Sorry, questions.
Sure.
Yeah,
Can you see
I
that?
guess you guys are not that familiar with word tidal locking and all, but let's see what's tidal locking. So the first question is, what is phenomena of tidal locking? If you guys know what is tidal locking, you can raise your hand or you can put the answers in the chat box. Okay, I'll be saying what is tidal locking actually. So it's the body has the same rotational period as its orbital period around its partner. Means like you can see here the Earth and the Moon, right? So the Earth and Moon will be having same orbital period and the same rotational period, exactly the same at the same time period. So that will be happening called as tidal locking. And let me go for the second one. What is the effect of tidal locking of Earth with the Moon? You can say the effects.
Maybe because of this, we only see the one side of the moon, and we cannot see the other side of the moon. Is it one of the effects?
Yeah, but it's not that exact answer.
Is it something to do with waves? I don't know.
Actually, no, not that. That will be coming for the third of the question. So you guys, you can even chat, put the answers in the chat. Okay, let me reveal the answer. Actually, what is the effect of tidal locking of Earth with the Moon? Is cause as Moon's gravitational pull will be on the Earth causes the bulging out of the Earth. So due to that, the closest side of the Moon and the farthest side of the Moon, like the closest side of the Moon will be bulging out towards the Earth. So that causes a tidal force on the oceans of the water on the Earth. So due to that, the bulging of water will be having a high tides. Due to that, we will be seeing the tides on the ocean edge or the coastal areas, you can see. And yeah, and guys, do you know why the tidal force is actually a force? Like why it is a force, you can say. Any guesses or any answer? Okay. I'll be saying the answer. Actually, tidal force is not an actual force. It's just a gravitational pull. Due to that, the tidal forces mechanism is having the oceans. And coming to the third question, is it possible for the Earth to get tidally locked with the sun? Okay, we have been talked with the moon right now. Let's go for the sun. Okay, if anyone, you can say. I think you guys can unmute and say that would be really very good for us.
No, I guess it can't be locked.
Yeah, it might be too far for that to happen.
Yeah, we could ask the host to unmute everybody because it will be more interactive for us to get the answers. And yeah, this is what I thought. So any cases, guys, with the Earth to get tidally locked with the sun?
Will we be stuck on one side? I don't know. I'm kind of going off here.
Okay, I'll be revealing the answer, right? So
Okay,
actually, no, because the Earth will not become tidally locked with the sun anytime. Because this side facing away would be cold for the one side of that will be cold and one side will be the hot. So due to that, it will not tidally lock with the Earth. And if it is going to happen, then it will be like 50 billion years after the sun dies, then only a sun and Earth can tidally lock. That is not possible, however. And yeah, I would like to hand over it to the Gauri.
Okay, thank you, Akshita. The next phenomenon I would like to speak about is smog. So on the left, you can see a smoggy morning in Los Angeles, how the light penetrates through the smog. And on the right, you can see a then and now picture of our New Delhi. The left side of the picture shows how contaminated the air is now due to smog. And on the right, it shows us how clear the air was. So smog seems to be a very interactive topic because I hope many of you know about it. So I'll be going on to the questions now. So what exactly is smog? I'll go to the first part of the question. Can anybody unmute and say what smog is?
Smog, is it just a mixture of smoke and fog?
Yes, thank you. I think it's Shreyas. Thank you, Shreyas. So what are the types of smog? There are different types of smog. So what are the types of smog?
There is, I think, photochemical smog and industrial smog, if I'm correct.
Yes, thank you. It's classical smog and photochemical smog. What you said is right. Classical smog is caused by the smoke from industries and all, and photochemical smog results from vehicle emissions smoke. So the two types of smog are photochemical and classical. And now, what are the most polluted cities in the world presently in terms of air pollution? The names of the cities in the world.
Delhi, New Delhi, Beijing.
Of course, ma'am. Yes.
Beijing.
LA.
Yes. Yes, another right answer. Any cities else?
Maybe Hong Kong? I don't know.
Yes, ma'am. So thank you. I'll be saying the answers. We have Lahore from Pakistan, Ghaziabad from India, of course, New Delhi in India, and the Dhaka of Bangladesh, cities from Mexico. And so when you look at the world rankings as per 2021 reports, we can find 3 or 4 cities from India itself, which shows how polluted our air is, how poor the quality of air around us is. That calls for urgent measures for clearing our, the quality of air around us. Now, one of the most relevant questions for this topic: can everybody suggest the methods to control this problem?
I mean that it's based on pollution, right? So we can
Yes.
control pollution, try to reverse that, means planting more trees and all that.
Of course, right?
We can put some measures on how to limit using of smoky equipment like cars or machines.
Yes, correct. So thank you. Those were the correct points. Reforestation and afforestation are to be given special emphasis, and vehicular emissions are to be reduced. And in between, another question: can anybody tell me what measure was implemented in New Delhi so that the vehicular air pollution could be reduced?
Odd even rule.
Exactly. Thank you. On alternate days, odd and even number plated vehicles were on the road, but practically it was not, under implementation, because of course it is impractical to do so. If I have an emergency, even if it is even numbers that are going to go on the road today, I'll be going out with my vehicle. So it again calls for the usage of compressed natural gas and other biofuels, reducing the emissions of fossil fuel, which can reduce the air pollution around us. So that is the case with smog. Now I would like to hand it over to Akshita again for the next topic.
Yeah, next slide. Guys, the topic is lava actually. You can see the GIF here is about lava. So Gavi, questions.
Can you see them?
Yeah. So guys, it is a normal question. What is lava actually? We have studied it from very, very small. You can say. What is lava?
It's just
Okay, I'll be going.
molten rocks,
Yeah,
right?
go on.
Molten rocks.
Oh yeah, it's a molten rocks. It's a hot molten rocks. So next part of the question will be like, where do they come from?
I think they
This is
come
only the
from
basic
deep
question.
underground. like under the ground and out of the volcanoes.
Yeah, you are correct. So it's a semi-fluid rock erupted from the interior of the terrestrial planets, like only the planet which is having a um, magma and its core and parts of the earth. And yeah. So can you classify the names of the lava? Or you guys know that lava is classified or not? Okay, let me say it. So actually, lava it is divided into two categories, like two classified things. So based upon its viscosity and uh, volatility, it is divided into two types. First one is Pau and second one is R. So you can see how weird these names are to pronounce. But even, this is even having a third type called pillow lava, and even also we have a blocky lava flow. So this pillow lava, it is from the submarine eruptions, like the you can say the lava from the ocean parts. And yeah, these are the classified names of the lava. Once again, let me repeat it: Oahu and Aa. Coming to the third part of the question, different types of lava have different speeds. Why? We all know that lava will be coming out and everything, but we don't know which kind of speed it is going to come or how it is related with the speed and all, right?
Also, the composition might have something to play.
Yeah, it is related to some of the composition. That is one point for the speed of the lava to come out. Guys, you can chat through your put the answers in your chat box. You know it. Okay, let me explain it if you guys don't know. So there are a type of lava erupted due to its viscosity. So the first different type of lava with its different speed is type of lava erupted and its viscosity. And second, how it is coming from the ground over, so it can travel through the canals, like in a canal way, how it is traveling, that is the second way. And third way, you can say it as rate of lava, that is vent. How much lava it is coming out through the vent. And you can say it as like as I said you before, like the speed of the lava can be like 10 to 48 kilometers per hour. So that will be coming out due to the magma with low viscosity have more flow easily. Like low viscosity equal to the flow of lava can be easy for the lava to come out. Like it will be going through the canals. And even due to the silica content also, the speed of the lava will be varied. So this is why the lava will be having different speeds with the different lavas. And yeah, and thank you.
Yes. So you still
Thank you,
have
sir.
10 more minutes. Yeah, you can wrap it up. Yes. Maybe you can showcase a few more slides and finish by 11:10. Yeah, you can go ahead.
Shreyas and Path.
Yes, yes. Yeah, there is a few more minutes, like 5 to 10 minutes to showcase few more slides.
Okay, hello, am I audible?
Yes.
Fantastic. I'll start presenting. So I'm presenting a presentation on lithium batteries. And so first of all, these are three pictures of a car, some a Nokia phone that everyone must be familiar with. And so what is common between these three things? So the common fact is that they all use lithium-based batteries. This is literally a stack of lithium batteries. Secondly, this is just a second. Is my pointer visible? There is a pointer. I'm going to assume.
Yes, sir.
Yep.
Thank you. So this is a generator, and this is a dam. I'm basically using this as a way to talk about energy densities. So now, assuming we have water in this reservoir, we'll get some X amount of energy from it. But what would happen if we have oil in the dam? Will we get more electricity or less? So the energy is dependent on the density of the liquid. So over here we will get less energy from the oil because it is less dense. Similarly, we can talk about energy densities of not just the gravitational energy of oil and water, but also the electrical energy densities of various types of batteries. Down here we see lead acid batteries have some of the worst energy densities if it comes to by weight or by volume. And over here we see that the lithium polymer batteries or the lithium ion batteries are some of the most energy dense most energy dense batteries that we have. Now over here we can see some the images of some landfills with the lead acid batteries and then other miscellaneous batteries as well. These things are notoriously hard to recycle from. But however, this is not necessarily the case with with lithium batteries, as is with lead acid and nickel cadmium. Here we have a chart showing the multiple types of processes for recycling lithium batteries with each of their advantages, disadvantages, what is getting recycled, what is good for recycling this material. And we have a variety of recycling methods which are quite good at taking back most of the harmful things that would otherwise leach out into the environment. And here are some references for the diagrams and the charts from my slides, as well as the information. So thank you. I'll conclude my presentation over here.
Yes. So yeah, you have maybe for 5 more minutes. So if you have something, you can sure. So okay,
I will take over for now. And
yeah. Okay, go ahead. Yes.
And yeah, I hope my screen is visible. And is my screen visible though?
Yeah, it's visible.
Yep. So yeah, we will go to this great thing the mankind has done to the earth. So it's the Great Pacific Garbage Patch. So what exactly is Great Pacific Garbage Patch and what has caused this problem in the first place? So Great Pacific Garbage Patch is a clump of plastic waste, and not only plastic waste, all different kinds of plastic products like nylon, plastic bottle cans, whatever we use, even they have been broken down into microplastics, and they have all clumped together to form a vast island in middle of the Pacific Ocean. So there are many clumps like this in different oceans, and there are two parts of Great Pacific Garbage Patch. One is East Pacific Garbage Patch and one is West Pacific Garbage Patch. And what has caused this problem in first place is our own activities, that we have been dumping so much waste in various forms, and they all make their route, somehow they make their route to into the oceans. And this has like tons of millions of tons of human plastic waste has been accumulated in these garbage patches. So now why has garbage accumulated as a patch and not spread evenly across the oceans? So as you know, in the Earth's ocean, there is a system called ocean circulatory system, where there are ocean currents which are themselves modulated by Earth temperatures, and these ocean currents flow across the entire Earth. So all the oceans are interconnected, and these currents flow all around the globe. So when we dump these plastic dumps into the ocean, these current pick these garbage like plastic products up, and eventually they like get sucked into a vortex kind of thing, and get accumulated as a big patch of garbage. So in this next poster, you can see how like there are different facts, but I will be focusing on this exact thing. So these blue lines that you can see are oceanic currents, and you can see in like they form a gyre. This gyre is a circulatory, a small, not fully closed, but kind of circulatory system in which they get trapped in eddy. So eddy is just a circular motion inside the gyre. So all the plastic products are picked up by these currents. So like you can see how these currents are interconnected throughout the globe, and this plastic gets trapped in this current and eventually make their way into this big plastic garbage patch. So even if we have proper satellite instruments, we can see this big garbage patch, which is almost the size of many of our states. Like it's bigger than the size of Andhra Pradesh maybe. And these microplastics and plastics cause so much nuisance to the fish living there, the ecosystem. And we have been finding small pieces of garbage, small pieces of microplastics, even in the Mariana Trench, which is the deepest trench in the world, like at the depth of 11 kilometers. And eventually, since all of our globe and ecosystem is one big interconnected system, these microplastics often find way into our diets also. And now it has been integrated in almost every aspect of our life. So the take-home message from this is that we must understand this, that plastic pollution is a big problem along with global warming as well. And we must come up with innovative solutions, innovative thinking process. Maybe we can cut down our plastic production and usage so that we can have a better and sustainable future. Thank you.
Yeah, thank you, ECS. I think we can, yeah, because of because of time constraint, we stop here, and I would like to thank all members who are actively involved with these presentations, the entire SCF club, for coming up with various phenomena in and around us, and engaging all of us with such a nice interactive session. So now we move on to the next exciting session, communicating science through art, the final competition. So before starting, I have a few words on this event. Considering that science communication is very challenging, and reaching out to a broader audience requires a simple yet captivating mode of communication. So we have invited SMS and PhD or IPhD students to submit their ideas in the form of dance, song, or an art, or a presentation, with a main theme of integrated approach in science and technology for a sustainable future. So I'll be displaying or playing the shortlisted art or video one by one. And I'll request the honorable judges, Professor Ambika, Professor Nagras, Dr. Sanchayan, and Mr. Mugras to kindly assist the same. So I will start displaying those entries one by one. So yeah, the first entry by Ayushman. Is my screen visible?
Yes, it is visible. You just have to open it.
Yeah. Yeah, I have opened it. So is it?
No, it's not open. You have to share your full screen probably.
Okay. So it is showing like a desktop one. Yeah, now?
Yes. Can you zoom out? Yeah.
Yeah, it's visible, right? Okay, yeah. So Aishman, you can just go ahead and then describe your art with few words.
Yes, sir. Thank you. Am I audible?
Yes, yes.
First of all, yeah, good morning to all the faculties and judges and every participants here. Um, so this is a small art piece which I drew. Um, I named it as Feathers of Sustainability. So keeping upon the theme that we have this year. Oh, first of all, I am a student of BSMS 2020. I am Ashwan Malik. This year we have the theme of integrated approach in science and technology for a sustainable future. So keeping in mind, I made this art. So what this art is depicting is that how can we prevent the post-agricultural losses in India and in a worldwide basis. So as we know, India is a agri-based country. Well, it's developing country. So um, as it is agri-based, so we can strengthen our agriculture more. So, but the main hindrance to it is the post-agricultural losses. According to researches, it shows that it's 10 to 25% wastage, means after the crop is harvested, 10 to 25% of the producible amount is wasted in transportation and other factors. So I designed this art. So what it shows is that first there is a green tree of mechanization, as we can see in the left corner. The first thing which we have to keep in mind that to prevent the losses, we have to start mechanizing each and every machinery. Means we have to um, stop the handmade or the human labor and start with the mechanization. That's the first thing to uh, mm, reduce the losses. So what we can see here is that green tree of mechanization. And then there's a peacock. Peacock is the symbol of rejuvenation and regrowth. In the belly of peacock, we can see the farmers, the one who feeds us, the one who uh, labors whole day long just to feed our children and our future generations. So I made the peacock such that the farmer is the life, means the life of India. They give life by producing crops to research and anything, any small things and any big things which we can do. So uh, we can see different colorful feathers of the peacock. I tried to depict in this way that the feathers are the different ways to um, produce a rich amount of crops. They are the different ways. As I showed many different colors, that it shows that there are different ways to cope up with this. Some of the ways I would like to discuss here are like starting from the leftmost corner, the hand and the shovel sign. Uh, I try to depict it that harvesting and threshing means if we do mechanical harvesting and we use machines like combines, and then we can if we do those, and for drying purpose if we use continuous flow dryers or something like that, Means if we mechanize the whole harvesting process and the drying process, then we can prevent the agricultural loss which is done by human labors or by handmade processes. Then there's that you can say a packaging from the leftmost corner above the shopper. I try to depict the storage. The main problem is storage in India. We have a good number of warehouses to store our grains, but how to store our grains such that they don't get moisture and the shelf life of storage increase. So in the actually there's a new technology which we known as the hermetic storage. Uh, it it's under that PICS company, a trademark company. They have created uh, this polypropylene. These are actually polypropylene bags. We can actually the Indian government has already started in a few states to use these bags. These bags can increase the shell life of normal staple crops like wheat and rice up to more than 2 or 3 months. Uh, yeah, I wanted to depict um, the hermetic bags, also known as the airtight or vacuum bag, something like that, uh, to prevent the loss of or the loss of staple crops. We can again we can use bags like not actually bags. We can use desiccant beads or silica gel in the storage or the warehouses to absorb the moisture. So actually, I drew that research and that the round bottom flask and that test tube to show that we can research more. We can there is always scope of research. If we research more, we can find out many other ways to cope up with this. Again, coming to the right side along the feathers, we have I have drawn a few things. I would like to explain it. Actually, it's all about the marketing. I think a big country like India and with so much population, we produce a well amount of food crop to feed us. But the main problem is marketing of them. Yeah, we know that rice and wheat has a wide market in India, and we also export and import them to other countries. So what I wanted to tell you by this side of the feathers is that we need to widen our market. Means uh, if we widen our market, what can happen? Uh, for example, at
Aishman,
present.
I think you've crossed the 3 minutes. Can you please wind it up?
Okay, I'll
you.
try. I'll try. So what I wanted to tell due to time, I don't have much time. So I want to tell that if we make the market a bit of systematic, then we can transfer the food crops to the consumers from the brand to the consumers very easily. So I would like to say a few more things that Indian government has also uh, took a few steps in this marketing thing, like introduction of the minimum support price and they have used a great system to distribute the food staple through PDS. The actually PDS is the fair price shops which they have introduced in different states. So that's a good way of marketing and delivering the products to the um, consumers efficiently. So that way we can see in the whole art I have done a graph. Means through all this a declining graph can ascend very easily in that way. And there is also, you can see the sky, that is a night sky, and there is a man in a hot air balloon. Actually those are the young scientists, the young brains which who can research more. And as you can see, the hot air balloon actually is a bulb which is lighting up. So actually um, we should research more on this and to find newer ideas. Yeah, that's I would like to say. Thank you for giving me so much time.
Sure. Can I ask him something?
Yes, I'm sure.
Yeah, Arishman, very nice. You have put together lots of ideas into a single painting. My question is, what is the medium of the painting? You use watercolor or acrylic?
I did it digitally using Photoshop software in the laptop and using graphic pad to draw.
Okay, good.
Unmuted. So we'll move on to the next entry by Komal. We'll share once again the screen. So again, screen is visible, right?
Yes, it's visible. Yes.
Okay, so I'll
बरसों बरसों बाद तुम्हारी राह सब रहे, बरसों बरसों बाद तुम्हारी राह सब तक रहे। बादल गरजा पानी बरसाए नदियां बचली चली चली, बादल गरजा पानी बरसाए नदियां बचली चली चली। के ऊपर बरसा पानी आई बत्ती हरी हरी, के ऊपर बरसा पानी आई बत्ती हरी हरी। बरसों बरसों बाद तुम्हारी राह सब तक रहे, बरसों बरसों बाद तुम्हारी राह सब तक रहे।
Yeah, Komal, do you have a few words to describe about this video?
Hello, am I audible?
Yes, yes, Komal.
Good morning, everyone. Thank you so much for giving us an opportunity. This entry is on behalf of the Anurakti Dance Club of IISER Tirupati. Would it be possible to make Sauparnika Sabu a co-host also? She would be describing the submission.
Yes, yes. Can you mention her name in the chat so that?
Done, sir. Done.
Oh, okay. Thanks, sir.
Thank you so much. Saparnika, over to you.
Yeah, hello, am I audible?
Yeah.
Yeah, thank you. So good morning again, everyone, and thank you so much for this opportunity. To start, we all know that the environmental issues that we're facing today is basically one of the terrifying realities of our time. And humans have been exploiting Earth out of greed for years. And if these keeps up, the food and water shortages, recurring disasters, and every other horrible scenario that we could imagine now might be just a tip of the iceberg we are about to hit. And this is what precisely we were trying to tell through the dance. In the 2 minutes performance, we are actually combined different styles of dance. We started off with Kuchipudi, a very small portion of Kuchipudi, where we were making use of mudras and Russians to take you to a peaceful world, where the trees and flowers were flourishing, where organisms both on money and greed into. We tried portraying the selfishness, arrogance, and ignorance of humans as we changed to a folk style with more defined beats. The human greeds keep cutting trees, killing animals, and destroying everything, ultimately leading to the death of everyone, including ourselves. This would be us if we do not start now facing that very predictable yet terrifying death. See, remember that the science tells us that we might still have some time to stem the tide, right? So in our dance, we move on to a rhythmic piece from Ritvis, combining Odissi and Kathak to show how afforestation and management could change the world for us. And finally, we ended it in a freestyle with some backing, depicting the freedom from the greed and the joy of nature and the better future for our upcoming generations. So, working on a project like this, which talks about science and sustainability through dance, was a very new, refreshing, and beautiful experience for all of us. We believe that the dance is like an art form that could stick to people's mind, engage and influence it. And we have really tried portraying what we felt about science and sustainability through this 2 minutes. And we hope that this humble attempt of ours would inspire you to take your next step towards conservation of our planet. Thank you.
Thank you, Saponika. So I'd like to request if judges have any quick questions to the students. Yeah, if not, ma'am, are you speaking now?
No. I just wanted to say good presentation. I liked it.
Okay,
Thank you,
so much.
ma'am. Thank you so much.
Yeah, so we'll move on to the so
Hello.
hi, please.
Yeah.
What's your name?
Hello everyone. So I've named this painting as Horns of a Dilemma. And the dilemma here refers to the tight spot the world is in due to climate change. And we see all the causes and effects of climate change around us. While looking at all this destruction, we also know and think about ways that could help mitigate the effects. But it so happens that the majority of these ideas remain in our head instead of bringing them down to action. So this painting is trying to depict the same, that we are all worried about what's happening around the world. We have innovative and scientific ideas for prevention and restoration, which are slowly being worked upon, but we may need to pace up and take appropriate measures to actually see them bring about a change in this situation that the world is facing. Thank you.
Yochan, how much time did you take for this? to complete it?
I actually took 3 days,
Okay.
but yeah.
What's the medium?
Painting, watercolor painting.
Watercolor on paper, no?
Yes, ma'am.
Okay.
So Rukmini, do you want
Hello? Yeah. So this painting is about the green energy, the renewable energy. Let's be honest, renewable energy is necessity. Harnessing virtually limitless energy from natural world, check. No dangerous carbon pollution in our atmosphere, double check. Some communities have done nothing to contribute the global warming but are already bearing the toll. It is time to rise up and be more responsible for our ancestors' actions. This is now or never situation where we have to find the prosperity. Let's innovate our buildings as energy providers and not energy consumers. Photons are wireless, fall on every rooftop, and generate enough power to be sufficient for every household need. The focus will be to use them. Yeah, thank you.
Good, Rukmini. I think this is also watercolor on paper, no?
Yeah, this is watercolor plus poster colors.
Books are also added.
Yeah.
Any specific reason for choosing red? Overall prominence of red color. Do you have any reason for that? Your argument?
Actually, there is sun on the top of her head. There is one woman standing, and the water waves are her hairs, and like there is no such a prominence, but like sun, that's why red and yellow, and there is like in the beneath of that, like, there is a crop field beneath of the painting. Yeah, and there are houses with the rooftop as having solar panels and all.
Okay, good.
Ishwar, are you putting up the next one? Hello? I think we'll wait for a couple of seconds. If he has any connectivity issue, one of us will present it.
Hello?
Hi, yeah.
Yeah, Rukmini again. Okay. Yeah, so if nature could have talked back to us, it would have been really pretty tough words. Doesn't nature speak back? Have you heard about global warming, floods, drought? Yeah, they are pretty normal words now. Nature is reciprocating. It holds our hand when we give it, but slaps hard when we try to tinker a finger on its well-being. The delicacy is in our hands, whether to treat it with the love and take it home in return, or to be rude to it to receive the wrath. The only feasible way is to find the balance. Let's sustain the balance to sustain our life. Thank you.
So, any questions from comments?
No comments. Good.
So let's move on to the next entry by Sanskriti. Again, it's an art. Sorry, in between I was muted. Okay. So yeah. So the screen is visible, right? Anu?
Yes, now it is visible.
Yeah.
If the other judges also have any questions, you may ask them.
Yes, please. Yes.
Good morning, everyone. Am I audible?
Yes, yes.
Hi, everyone. I'm Sanskriti Saxena of BSMS 2020, and I would like to tell about my thinking on Science Day through my painting, whose caption is Dreams into Reality. Who could have ever thought that a country colonized by the so-called supreme, the powerful, could have the potential to fight back? Amidst of all the favoritism, secure a Nobel Prize, lack of resources, still we managed to build up the first rocket, eyes watching from all over building a nuclear power station. Yes, I am proud to say, but we did it. And it was no more than a dream for change, a dream for India, a dream that could make this country of 135 crore citizens self-dependent and proud of itself. The picture that I have made comes from the 1900s when the news channel mentions that India will reach its sustainable goals by 2022. Besides the television, a pregnant lady stands watching the television. The baby in the womb, who is unaware of the conditions outside, builds a dream of how his country will reach its sustainable goals by 2022. The child is dreaming of a country about natural resources and their uses in a thoughtful manner so that their generation can also witness these resources and use them. The child is also dreaming about a country where an alternative fuel can reduce the carbon footprints, water management systems such as artificially intelligent water pumps that can measure the groundwater level, recycle PET bottles, PET bottles, and their usage in creating creative art materials and yarns, making farmers self-dependent through various techniques such as precision agriculture, drones to capture spectral images to capture current soil and crop conditions, app-based system to bring the entire farm to their mobile phones are some of the developments, switching completely from fossil fuels to solar and wind energy. Many of the above dreams now have turned out to be true, but still needs to be implemented and practiced at a mass level. My painting appeals to all those young minds out there to observe and be curious about their surroundings. It is you, your thoughts, and your ideas that can make a difference. It is not the technology, but our approach and mindset that can bring a difference. Keep dreaming and keep the scientific side of yours alive. Wishing you all a happy Science Day. Thank you.
Can I ask a question? This is Nagaraj.
Yes, sir.
So what is the significance of 1990?
Actually, the painting, when I was building up, I asked my father to tell about what changes he has observed in his time, like when he was a college student, and what changes I can see in my time. So that's why it goes to the 1900s.
But nothing special. That's all.
Yeah, as of now, nothing, but that comes from solo idea of asking my father.
Yeah, good presentation.
Yeah, any further comments or inputs? So, yeah.
And so this is mostly sketch pen, no? Sketch pen
Yes,
and
ma'am.
ink.
Sketch pens and colors. Yeah.
Colors. Colors, which color you used?
Normal crayons, ma'am.
Crayons.
Yes, ma'am.
Okay, then. Good.
So, okay, then we will move on to the last entry by Devi Datta. It's a kind of presentation. Again,
Ishwar will have one more dance by Smriti.
Yeah. Okay, shall I allow do it after Devi Datta's presentation?
Yes, sure.
Can do it
Soon
right.
after Devi's. Yeah.
Okay.
One question that always comes to our mind.
Yeah.
You're still not presenting?
Yeah, I'm sharing.
Not seeing the presentation.
Yeah, so my screen is visible, right?
Yes.
Okay.
One question that always comes to our mind is whether the microbes are good or bad for us. When I was in my school, I used to think that microbes are always the villain of our body and ecosystem. Community to enhance the growth and development of a plant. So it can.
Ishwar, it is not audible.
Nutrition demand. Why? Because it is rich in protein, healthy fat.
Anu, what about now? Am I audible?
Yes, yes.
Say okay.
And
So okay now. It's
Yes.
audible, right? Okay,
Yes.
okay. Then let me play it from starting. Yeah, sorry.
One question that always comes to our mind is whether the microbes are good or bad for us. When I was in my school, I used to think that microbes are always the villain of our body and ecosystem. But we can use those good microbial community to enhance the growth and development of a plant. So it can be used as sustainable approach in agriculture. The plant I have chosen here is groundnut. And this is an alternative approach to address the nutrition demand. Why? Because it is rich in protein, healthy fat, and fiber. It also gives us groundnut oil. It can be used as source of vitamins and minerals. It can be used as fodder for livestock. And also it is always environmental friendly. Our country is the second largest country to cultivate groundnut. But even though we are having those huge amount of arid and semi-arid region in India, still there are challenges that come in between the groundnut cultivation. Those can be biotic factors or abiotic factors. Biotic factors like fungal infection, bacterial infection, and viral infection, those result in reduction of the plant yield. And there are certain abiotic factors, those are the result of environmental change like high temperature, salinity, drought, and pH. High pH, they result in stalled growth, quality and quantity reduction of the plant, less reduced oil content of the plant, and also they make the plant susceptible for pests and diseases. What we are looking for? We are looking for a sustainable approach that can help our plant in growing in a better way and environmental friendly. So what we got, this good microbial community, they can help our plant to grow in a better way. So where we can find this microbial community, they reside in the territory of the plant. The microbial community that stays in the root region, we can call it as rhizosphere microbiome. The microbial community that we can find in the leaf region, we can call it as hydrosphere microbiome. And the microbial community that stays inside the plant, maybe inside the seed, that we can call as endosphere microbiome. What these microbial communities do, they actually help the plant in nitrogen fixation, nutrient uptake, phosphate solubilization. Also, they help the plant in antioxidant enzyme production, as well as we can get different phytohormones through these microorganisms. They help in biocontrol and they also enhance the stress tolerance of the plant. So we are getting a microbial community. So we just need to make a synthetic microbial community that will have all these good traits. They should, what we want, those community are called as synthetic microbial community. They should be colonized robustly. They should be having growth promoting traits, and they should be there predominantly in all the growth and developmental stages of the plant. After getting this microbial community, we can apply this microbial community either to sole crop or the crop with intercropping system. Why we are using intercropping system? Because each plant has their own microbial community. And if we will intercrop two different crops, that may be pulses or different crops, so we can have an enriched microbial community. After having this enriched microbial community, our plant will grow happily and our plant will be healthy so that we can save our crop in an environmental friendly way. Thank you.
Yeah, thank you, Devidatta. So any questions from the judges?
Yeah, is this your research work?
Yeah, sir. It is not my research work, but the work I have interest in. Yeah,
Oh,
one
but
of
you
the,
are pursuing this kind of thing. That's what you say.
yeah.
Is it?
No, I am pursuing my research on abiotic stress.
Oh, okay.
Yeah.
Different from
So this is an alternative approach to address that.
But
Yeah, so if there are no questions, then we'll go to the next entry. So yeah, can someone from Outreach Committee can start sharing the screen, maybe.
Yeah.
Is it BSMS or PhD?
BSMS. I can present it on my own if it's okay, or if it's
Yes,
ready
yes.
with you.
Yeah, that will be great. Yes,
Yeah.
please go ahead.
Okay. Yeah. Thank you. Yeah, is it visible, sir, on the screen?
Screen is visible. Yeah, screen is
Yeah.
visible. Yeah,
Yeah,
maybe.
all right. Let's start. Yeah.
Yeah.
Barter to Bitcoin. Human transactions have come far since the Stone Age. This is an effort to depict the journey from barter to Bitcoin through one of the Indian classical dance forms, Bharatanatyam. Barter system, where the commodity trading was carried out, is known as an old method of exchange. People started exchanging services and goods for other services. Metal money coins were made from the stamped pieces of valuable metal such as bronze, copper, silver, and gold. They allowed people to pay by count of number of coins rather than weight. Paper money. With the introduction of paper money, the lighter weight of the paper money allowed for international trade. The introduction of banks. Banks offered loans and accepted deposits from individuals. With the introduction of banks came the bills of exchange. A bill of exchange is a written order that one person or group will pay a specified amount of money on demand. Use of credit cards and debit cards started. Digital payments. They are transactions that take place via digital or online modes, with no physical exchange of money involved. The PMP use electronic mediums to exchange money. Bitcoin, the best known and a growing constellation of cryptocurrencies, is an increasingly popular virtual money. Even more abstraction than digital dollars, it is simply a series of balances in a decentralized online ledger known as the blockchain. There are no physical bitcoins. Using what's called peer-to-peer technology, cryptocurrencies remove middlemen like banks and the government, allowing direct transactions between a vast community of users. Yeah, that's all.
Yeah, thank you, Smriti. It's such a very nice dance. So I'd like to request judges to
Yeah, I would like to speak a bit first, if it's
Yes,
fine.
please. Okay.
Yeah. So good morning, everyone. This is Smriti from BSMS 21. Very happy Science Day to all the science people out there. On this event of communicating science via art, I made sure not to miss out on commerce. The topic I chose is the evolution of Bitcoin from barter system. Money is equal to value. Now, since ages, money is represented by different things. Like people in the Stone Ages used a barter system as a means for buying stuff in exchange for the goods they produced. Now, soon people realized that they got to have a medium which is viable for a good duration.
Thus came up the theory for coins, which evolved to paper money because of weight downside, followed by DDs, credit, and debit cards. The age most of us are living in is digital. Now, the most challenging part here is to keep track of transactions, which needs a centralized bank system. Then comes the protagonist of my story, the top Google search, cryptocurrencies like Bitcoin. No, Bitcoins don't have any physical existence. And because of the distributed and blockchain form, it makes the system impossible to hack and also removes the involvement of the third party, thus making you the boss of your own and thus solving many challenges like money risk, corruption, non-transparency, legality removal. Now, Bitcoin is an automated structure which doesn't need any coding or programming, but the algorithms need a computer. Now, to maintain such thousands of computer, we need a third party looping us back to the square one. Here comes the concept of Bitcoin mining. Now, the areas where we can improve Bitcoins is by making it acceptable globally, reducing illegality and volatility. Now, Bitcoin is legal in India, and also the return of investment is super high. Thus, investing smartly can give profitable results. Thus, technologies for sustainable future doesn't only mean about the sustainability of earth and environment, but this remarkable evolution of science and technology is improving from decades, and Bitcoin will definitely lead to a very techy and smart future. Thank you.
Okay, Smriti. A good piece. I'm not seeing your face, therefore I have a question. Are you the performer?
I'll just, yeah, 1 second.
Yes.
1 second. Actually, I don't have a webcam on my laptop.
No, that's
right
okay.
now.
Okay,
Yeah.
but my question is, are you the performer there?
Yes, I am.
Okay,
yes,
that's it. Okay, good.
Is it this? I don't know anything about cryptocurrency or anything, but are you foreseeing that it is going to be like what we are seeing about credit cards and such things? Going to be as useful as?
Yeah, of course, even more useful, because as I mentioned, it is a much more efficient system, and the chance of getting hacked are even less. And the way your money could be invested is much, if you invest your money more smartly, there could be many profitable results here. And because the credit cards and the internet banking system that we are following right now, it involves a third party like a bank, right? So the involvement of the third party like bank makes very difficult, makes the possible reasons, the possible occurrences are of corruption or non-transparency, or your money can get lost easily. Because, for example, if we invest something, the bank takes your money and gives to somebody, and if the bank messes up and loses your money, you become the target. And here, using Bitcoin system, it provides, it doesn't, like that doesn't happen. So we get many advantages here.
No, why is that? Is it because it's centralized, or what is the reason?
No, sir. Here, no centralized system works. Like, there is no third party involvement here. If I want to make a transaction using Bitcoin, I'll just buy a Bitcoin address and transfer it to another Bitcoin address. So there is no involvement of any bank or no third party. It becomes much more easier that way.
So, but you need a lot of mathematics for this, right? Meaning behind the scene, not the people who are using it. But are you familiar with those kind of things?
Not much, sir.
Are you interested in that? Are you interested
yes,
in?
Yes, because the whole generation is going to transform into that. So it's better if you know about those things beforehand.
Okay, thank you. Nice presentation.
Yeah, any questions from judges and also the participants?
Yeah, can I ask one question, Ishwar?
Yes, please. Yes, please.
Yeah, to Smriti. Yeah, it's a very nice topic, actually, the cryptocurrency. So the one problem with the cryptocurrency is its volatile nature, right?
Yeah.
The value goes up. And so do you think like if it is like controlled, I mean, regulated in terms of price, in terms of volatility, it's fungible. It should not be non-fungible, right? So the value should remain fixed. So if the value remains fixed, it will be a better thing. Then we can the corruption can be because actually the good point of Bitcoin is you can track down from the money from the first person to the last person who has given to whom, right? So but the only problem is the volatility. So how that volatility can be, so do you think it will be a better choice if the value remains same of the Bitcoin?
So, but the whole concept of Bitcoin is that we get profit because suppose if I had invested one Bitcoin in like 2008, it's an actual data. In 2008, the value of one Bitcoin was 0.4 paisa or something, and in today's generation, the value of one Bitcoin is
more buyers are there, so the value goes up if the more buyers are there.
That's a major bad drawback.
Yeah, that's a drawback. But if we keep the value fixed for that, for example, one Bitcoin is say 1 lakh rupees, but it remains fixed, then we can track down and use it as a currency. Then it will be a better choice than remaining it as like a volatility, because that's a problem. Most countries are not coming toward it, right?
Yes, that's also one of the reasons why it has not yet been implemented permanently.
But it's very, very nice that you're reading about the Bitcoin. It's a new generation thing, right? So it's good to hear from you about the blockchain and about the Bitcoin. Yeah, thank you so much.
Thank you so much.
Yeah, so great. So yeah, I think if there are no further questions, I'd like to thank all the participants for active participation and for coming up with such a wonderful portraits on communicating science through art. Please note that the winners will be announced tomorrow afternoon. And I'd like to thank all the judges, Professor Ambika, Professor Nagaraj, Mr. Mugaraj from IISER Tirupati, and Dr. Sanchayan from IIT Tirupati for their kind help and support in scoring the entries. And also, I'd like to take this opportunity to suggest all the students to learn and adopt the best way to communicate science through the art. And based on the inspiring examples that have been illustrated by the address from Professor Ambika in the morning. And let's move on to the next session on ISM Indian League Initiative. So, Arun,
yeah,
is there someone from
Shruti, Shruti.
Okay.
Hello, thank you so much for having me, and it's a great pleasure to be here on Science Day. So my name is Shruti Sridhar, and a quick introduction. I'm this year's director of the IGEM Indian League, which is one of the latest initiatives from IGEM. I have with me a couple of members from my team, Omkar Date, who's our head of communications, Priyant, who's our chief of operations, and Kavisha as well here, who's part of our communications team. So I have a short presentation prepared to just talk to you all about what we're trying to do this year and give a brief history about IGEM as well. Let's go ahead and share my screen. Is my screen visible?
Yes, Shruti.
Okay. So the IGEM Indian League, as I mentioned before, is one of our pinnacle initiatives from IGEM for the year of 2022. So starting off with a little bit about what is synthetic biology. So I see that there's going to be a session by the IGEM Tirupati team tomorrow, which is it's going to be super exciting and give you all a lot more details about the history of synthetic biology and what you can do with synthetic biology. But in brief, it's a very interdisciplinary science. So it borrows from bioinformatics, molecular biology, computer science, engineering. In essence, you're trying to do modular, reproducible research using biology. So you have biobricks that are modular in nature that you can now assemble to and translate to function. And the whole idea here is to again create real world impact, and it's a multidisciplinary collaborative research environment. So a brief history of iGEM and how iGEM fits into synthetic biology. So way back in 2003 at MIT in Boston, the synthetic biology course was started by 20 odd people who decided that synthetic biology is the next wave for students and educators alike, and it's a new way of thinking. And they put together a synthetic biology course that ran a couple of semesters, and soon they realized how excited students were and the kind of problems students were solving because of this. And this year, in 2019, we have 600 odd teams from across the world, 300 odd teams from across the world, and an alumni network of around 60,000 iGEMers who take part in this competition year on year, every summer. And the whole idea here is to empower local people to solve local problems. So you, with your vision on how to create and affect change in the world, can you now use synthetic biology to champion this change? And that's the philosophy of iGEM. And this picture was taken in Boston again in 2019 and this year we'll be having our iGEM Jamboree in Paris in 2022. So exciting things to look forward to. So the iGEM Indian League now is to sort of create a self-sustaining ecosystem within our country, the Indian subcontinent, specifically in this niche. So we spoke to multiple iGEM teams and mentors and professors, and we realized that there are quite a few pain points that different cohorts face in the country, be it a lack of streamlined opportunities or translating efforts into synthetic biology and channelizing it, or just in terms of mentors or a mentorship pool in this field. So to that, we've tried conceptualizing a self-sustaining system, and this shows the convergence of your high school, your undergraduate, as well as your postgraduate and educator strata into one. And we envisage hosting like an annual SynBio competition to be held for the undergraduate collegiate teams. And we have a program that's shortly going to be released for the high school. And we also have courses for educators and mentors who are interested in knowing more about synthetic biology or taking their projects forward. And we essentially want to create like a network where people can interact, where it's a hub for high schoolers, educators, and all stakeholders to meet and interact and forge partnerships. And much like our Giant Jamboree, but running synergistically, specifically tailored to the pain points that India faces. So a little bit about our different cohorts. So for the high school cohort, we have a synthetase workshop that's happening very soon. And it's a 15-day workshop where you get a chance to interact with professors and mentors from various places and essentially get introduced to synthetic biology. And we have a small auction or like a mini synthetic biology hackathon towards the end where students can take part in it and showcase their project. We initially had created a similar high school workshop last year called the ATGC workshop. So it was a small pilot project that we did and we expected around 80 registrations, but we got 420 odd registrations. So that really showed us that children are interested in such an initiative and would like more opportunities like this. So this year we've scaled it up, made it much longer, and we have a synthetic biology auction for the high school students to look forward to and actually see their ideas being realized and taken forward. So a little more details about like the upcoming workshop. It's from the 8th of May to the 22nd of May. Our target audience is 8th to 12th standard students, but it's open to all, including teachers or or professors who would like to know more about this space, especially when it translates to high school students. So we have 12 days with 36 live hour learning and a 2-day hackathon event. And we've also had custom resources and handbooks that we've exclusively created for our cohorts as well. And essentially get a chance now to access the after iGEM networks, the entire iGEM networks as well, and meet national scientists and entrepreneurs and have a chance to interact with them about what's next, not just with their careers, but also in terms of the SynBio space as a whole. For our undergraduate program, we have a competition that is planned, which is going to run from the months of August through December. And before that, June and July, we have a custom training workshop that would be done for 2 months for all undergraduate teams. So we realized that launching into the competition directly is a huge learning curve for a lot of teams, and it's something that is a uphill challenge. So we created training programs so that we would introduce the foundations of synthetic biology and how to think of a project in synthetic biology. What are the elements that you need to include? And lastly, how do you translate this now to the real world market? What is bio-entrepreneurship, and how do you get started with that as well? So these are a few outcomes that we are looking at with our training program. And after they finished our course, the teams would start our competition season running for 4 months and culminating in our Jamboree event. And we also encourage first year and second year students to participate. So we use this as our as a way to sort of experiment on what are the limits of synthetic biology. In case you need any resources, we are here to provide them for you. And then maybe take it forward with iGEM Global or however you choose. And lastly, the Educator Program. Here we are aiming to train the next generation of SynBio educators. So how would a mentor look like for high school students, for undergraduate students? And we essentially want to equip participants with skills related not just to synthetic biology and iGEM, but how they can take it back and make it suitable for their campuses and their institutes and community. Essentially give them skills to tailor this to their specific community needs and teach people about the skills and value of synthetic biology and the impact that it can have. So we foresee this to be around 3 to 4 week training course run throughout the year for postgraduate students and educators, essentially people willing to become mentors and add to the mentor pool for high school and undergraduate students. Just a quick look at our dates and our registration fees. So a high school competition, as I said, registration is going to start really soon on March 14th. We have an open office hour coming up and we'll share details about that as well. So in case you or anyone you know would be interested, definitely ask them to attend our open office hour where we'll run in detail about how the workshop is structured, what we're going to do, who our speakers are, and how we're going to run through the 14 days. And our undergraduate registration would start right after, at the end of March. So here again, we're looking for teams of 10 or more who would want to sort of start their SynBio journey and kickstart their synthetic biology careers. So yes, thank you so much once again for having me here. And if there are any questions, we'd be happy to answer them.
Yeah, thank you, Shruti, for a nice presentation on IISER Indians in League. So I invite any questions from the audiences. Yeah, please go ahead.
So I think Onkar has shared all our white papers, our open office hour, as well as like our ways to contact us. So if anything, you can drop us an email or follow us on our social media handle, and we'll be ready to answer any questions and help as much as we can.
Yes. Thank you, Shruti. Yeah.
Thank you.
Yeah, so I'd like to thank all the participants and who are also on YouTube for their participation. So I'd like to thank the judges for taking the time to attend and scoring the entries. I'd like to request if the judges, Professor Ambika, Professor Nagaras, Mr. Bugaras, Professor Dr. Sanchayan, have anything to share with us. Professor Ambika?
Yes, nothing to share, but I was thinking that maybe we can have a brief discussion after this, immediately following this, once everybody has. All the students have, I can see that the students have taken some time and efforts, and they have good ideas.
Right.
Really nice ideas into their paintings and performance. I really enjoyed them. Thank you all.
Yeah. So I'd like to request Dr. Anu to, come up with the end note out of thanks.
Thank you, everyone. I would like to say that this has been a wonderful session, and we were very skeptical about the communicating science through art. With the students, never surprises. They have come up with interesting, entries, and as this was the first step, we've already, seen that there is a lot of enthusiasm from your side. I hope going forward we can have much more, exciting events on this lane, because art form is something that is far reachable to wider public, and science communication has a lot of, impact to reach out to broader audience. I would like to thank Celestic Club as well as ECS Club for taking their time to come up with these nice presentations today. And I would also like to thank all the participants today and the audience. And special thanks to Professor Ambika, Professor Nagaraj, Dr. Sanchayan from IIT Tirupati, as well as Mr. Murgraj, who have helped us to score these entries. And outreach team is very thankful for all the support from the students who have helped us, prepare the flyers, reach out to a wider, audience and so on. So this session will continue tomorrow in the morning. As you know, there are two quiz competitions that are happening. One by Shemashi is going to be open to all on YouTube, and the other one, Escape Room by Synergy Club, is going to be a closed event because they need breakout rooms and all. So in the afternoon, we have interesting lineup of events, having a distinguished speaker, Professor G.D. Yadav, and opening remarks by Professor K.N. Ganesh. And in the morning, we have Professor Ramesh Sonti, our head of the Department of Biology, who will address the students. And we also have, IGEM team who has won the gold medal, and we call them the hat-trick gold winning team, who is going to give their presentation, and they're going to also share their experiences with us. And we'll announce the prizes for all these competitions tomorrow. So please join us tomorrow, and we look forward for your active participation. Thank you, everyone. And last but not the least, I would like to thank Mr. Arun Sairam from the IT for all the support he extended to us, despite it being a Sunday today. And thanks for the IGEM team, IGEM India League, for joining us today. And I hope we can reach out to a lot of schools and colleges in the near future in collaboration with you. Thank you. Take care. Bye.
Thank you all.
Yeah.
Yeah, then maybe outreach committee stay back and have a discussion with Professor.
Yes.
Are we still live on YouTube?
Yeah, Mr. Arun, can you stop this on YouTube? I'll just quickly check with him.